BGP sessions are established between the Kubernetes cluster nodes and the Tor for IPv6 address family, as well as with route reflector for the VPN P.4 address family. Now is the time to define the locator pool. Each of the Kubernetes cluster nodes will effectively behave as an L3VPN PE device, and it needs SRv6 locator, and that locator will be then used to allocate the functions from, and finally seats will be used. Based on that, seats will be constructed from the transport network perspective. The same goes for PE devices, but they have SRv6 locator defined manually using the CNI. For a Kubernetes cluster, it's done slightly differently. We need to define the locator pool, and from that pool, every node will get SRv6 locator allocated from. So no pool defined yet. I hit the button, and what are the parameters to define the pool? Pool has a name, specific prefix of choice. The behavior type of the pool is either use it or base. We seek to use it in our use case example. Then there are several parameters that define the structure of the prefix and how the functions will be allocated and how the locators will be allocated per node, etc. So that's all defined in these parameters. And last but not least, there's also a label that will be then used by BGP, and that label will control whether the locator is BGP advertised or not. We, in this use case, we really want the SRv6 locator to be advertised over the BGP, so we make sure that the label and the value is the right one. I hit create, so it's created successfully, but if I go to CRD to see, that's exactly what has been pushed via Kube API to the Kubernetes cluster based on the inputs in the UI. Moreover, every isovalent SRv6 seat manager object will actually keep the status of the seat allocations. Nothing is allocated yet. Let's see why. Cilium Locator. It should be allocated. Maybe that's just a glitch. So we have every cluster in the node receives a locator of the length defined by locator length bits from the prefix defined here. So up to here was the prefix, and then the latter part is pretty much randomly assigned for every cluster node. So that's what happens on the kube cluster. What result it will have on the network? If we go to a network topology diagram and I hit P5, that's the Tor, that's where we have IPv6 advertisement. You see that it has changed from 1 to 2, and it means that every peering will advertise its own /48 locator node. What's not shown here in the diagram is that the P5 will have a configuration that will redistribute BGP into ISIS, because ISIS spans P5, P11, all of that core routers. ISIS does not go to kube cluster. The P11, P21, etc., those SRv6 locators, they go into ISIS by default, I would say, or as per configuration of the nodes, either or. Here, we need to make sure that these locators advertised via BGP will enter ISIS. So all the nodes in the network will know how to reach that locator address. And that's taking place because we do BGP to ISIS redistribution only.